Here we go, number 61 on page 456, 55, whatever. Now, passengers average 190 pounds. It says that. Let's see. Standard deviation of 35 pounds. And weights are not normally distributed. Okay. Commuter plane carries 30 passengers. Explain why we cannot calculate the probability that a randomly selected passenger weighs more than 200 pounds. Well, they don't tell us that the population is normal. If they did, we could do it. Okay, that would just be for like a single person. Find the probability that the total weight of the passengers in a full flight exceeds 6,000 pounds. Now that's okay because we are going to take 30 people. Central limit theorem applies. Okay, now if we calculate 30 people, right, 6,000 pounds, if you divide that, that's going to be 200 pounds per person on average, right? The average weight would be 200 pounds. So, well, let's see, what do we got to do? Same thing we've been doing, right? What is it? It's going to be a z-score. Weight z-score. So the average is 200 versus what we think the population is. And then we got to get a new standard deviation because we're taking the old standard deviation, which is 35, and we're going to divide it by the square root of our sample size, just like we've been doing. Okay, let's see what that looks like. And the z-score is 1.54. And we're going to do normal CDF and blah, 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 all like that. What is the probability on this one? And so there's 0.0, so when you do normal CDF, 0.0594, so about a 6% chance that the average weight would be 200 or more. Okay, that's that one.